In this review of the example problem from class, I'll take a look at a bending stress-strain analysis problem. We had a beam. It was known to be aluminum. The geometry of the beam is given, and it's loaded with a 10-kilogram mass. So we stepped through the calculation of the force, moment, and area moment of inertia. And the part that we didn't have calculations for was the stress and strain. So if we look at the numbers for force, maximum bending moment, and the area moment of inertia, we can use these values to calculate the maximum bending stress on the beam. And so the maximum bending stress will be as far as you can get away from the loading and on the outside of the beam, with tensile stress on the top of the beam and compressive stress at the bottom of the beam. So we use the maximum bending moment. Because we're on the outside of the beam, we use half the thickness, and the area moment of inertia is what we calculated for a rectangular cross-section of width W into the page and thickness T, which is the height from top to bottom. This comes out 8.8 times 10 to the 6 Pascal. That's a megapascal. So you could change the prefix there for a convenient unit of pressure or stress. And this could be for any length along that beam. All you would do is change the length that you use to calculate your bending moment. So this applies to the strain gauge lab. If you were using a length of, say, L/2, where you affix the strain gauges, then you would change the L, the distance used there for the bending moment. To calculate strain, it's no different than in axial loading. Here we just take the stress over the Young's modulus of elasticity. So the only step that's really different for bending is the fact that the stress is linearly variable with respect to the thickness through the beam. And so we can't simply use that F/A for axial loading. We have to take into account the bending moment, the area moment of inertia, which is a measure of how much it resists bending, and the thickness of the beam. So hopefully these values help you work through that example from class. For those of you who weren't there, for those of you who were in the section where we didn't quite get through these last two calculations. If you have questions, stop by or email.